All right, we're going to get started on Unit 7. We're going to be talking about exponents and exponential function and all of those things. We're going to start out by learning a few rules and applying them, general mathy stuff. No big deal. So we're going to learn in this lesson, we're going to learn two different rules, okay? So what are exponents? At this point in your math career, hopefully you know what an exponent is. We're talking about powers, not the powers that be, but just exponents, like this guy right there. That guy is an exponent. That happens to be a exponent of 2, right? Or if we have a 4, that's an exponent of 4. Now, what do they mean? Again, hopefully this little chant here at the beginning is, you know this already, but if not, no problem. That's why I'm doing it. So what does it mean? So if I have x cubed, that's the same as x times x times x, right? So that's what we're talking about with exponents, right? Now, there are two different parts when we're talking about exponents. There is the exponent itself, which is this guy up here. And then there is the number at the bottom. That's called the base. Okay. All right. So the first rule that we're going to learn with exponents is if we have like bases, so the same number or letter, right? Like bases multiplied. We have like bases multiplied. So let's say we have x squared times x cubed. So see, the bases are the same. The exponents don't have to be. If we have like bases multiplied, then we add the exponents. Okay. So this one, in this example, it would be x to the 2 plus 3, which is the same as x to the 5th. Let's do a couple examples with this. Okay, so let's do, some examples. This is example 1. So it is going to be 6n cubed times 2n to the 7th. Right? So we have a couple of like bases here and here. N and n are alike. We also have some coefficients here in the front. If you remember from probably way back, the number in front of the variables are called coefficients, right? So what we do with those is we do the same thing we'd always do when they're multiplied is, multiply them. And so 6 times 2 is 12. And then we've got like bases multiplied, so we add the exponent. So 3 plus 7 is 10. So this turns into 12n to the 10th. Let's do another one like that, and then we'll learn a second rule, second property, if you will. So example number 2 is going to be 3p t cubed times p cubed t to the 4th. Okay. There we go. So we don't have anything to multiply 3 times, so 3 times 1 is just 3, right? And then the p's are alike, this one and that one, and then the t's are alike. So remember, if there's nothing there, there's a hidden 1, right? So we've got p to the 1st times p cubed. 1 plus 3 is 4. So this turns into 3p to the 4th, t to the 7th. All right. Right. Now, the next rule that we're going to learn is if we have what I like to say is we have a power to a power. Okay? So like if we have x to the a and then to the b. So if we have a power to a power, we multiply the exponents. So in this example, in this definition, if you will, it's x to the a times b, which would be x to the ab, right? So let's do an example or two with this rule. So we're going to simplify. This would be example 3, right? It's going to be in green because why not? And because I forgot to change colors. Fine, no big deal. We're going to have 2 cubed squared to the 4th. Okay, so we're going to do like we normally do with grouping symbols or parentheses. We're going to work this from the inside out, right? You could actually kind of do it all at once, but we'll give us some best practice and not do it that way. 2 cubed squared. So we're going to do 3 times 2. So 2 to the 6 to the 4th. Then we're going to multiply those. 6 times 4 is 24. So this equals 2 to the 24th. Which would equal a great big old fat number, right? You can punch that in a calculator if you want, and you can get a long old number. But that's for this lesson. All we really care about is what we do with the exponents. Let's see. So we're going to look at a circle. Example 4. Example 4. I didn't notice this example when I was making this thing, so I didn't make a pretty circle, so we're not going to worry about a pretty circle, and we're just going to, that's mostly a circle. Sure, why not? Looks right. And then we're going to label the radius of the circle as 2xy squared. Now, what we want to do is we want to find the area. The area. Whoa, that's not how you spell the, is it? The area as a monomial. Okay, so how do we find the area of a circle? Well, the formula for area of a circle is A equals pi r squared, right? Right. So our r is this guy right here. So just like any other substitution problem, we're going to write the variable, we're going to write the formula with parentheses where we're substituting. So area equals pi times parentheses squared, and then we're going to plug our radius in there. All right? So now we've got all this raised to the 2 squared, right? Excuse me. Now, what this does is when we have a product to a power, it kind of distributes, basically, right? So this 2 applies to everything. And so this turns into pi times 2 squared times x squared times y squared. We can pull the coefficient out to the front. 2 squared is 4. And then we've got times pi, so 4 pi x squared y squared. There it is. There's your monomial. I know, it's a little scary. We got an answer. It's not just a number. What are we going to do about it? Nothing, because it's fine. It's right. Quit worrying about it. You don't have to end up with numbers. In fact, the higher you get in math, the less you end up getting numbers. You end up going to a theoretical math class, and like all your answers are just words. Wait till you get to geometry in in next year. Half the thing is not just words, but it's like a whole dadgum paragraph. You'll be fine. You can do it. We're going to do one final example that melds these skills together, and then we're going to be done. All right. So we've got 3 x y to the 4th squared times negative 2 y squared to the 3rd power, or cubed. Okay, now, I know it looks like a lot. I know you're freaking out. It's going to be okay. It's really not that hard. We're just going to take it a piece at a time. We're going to jump in and distribute this 2. Now, inside here, this y is to the 4th. So we've got a power to a power. When we've got a power to the power, a power to a power, we're going to multiply those, right? So we're going to do 3 squared times x squared times y to the 8th, right? 4 times 2 is 8. And then this one, we're going to work, we've got double parentheses, right? So we're going to work from the inside out. So we're going to distribute that guy. Now, this one is kind of a little bit tricky in a way because this negative 2 is squared. And a negative times a negative is a positive. So negative 2 squared is positive 4. But I'm going to, since like I did it on this one, we'll get that in a second. So negative 2 squared y squared cubed. All right? No problemo. So now we're going to take and we're going to distribute in this guy. So, excuse me. So, we're going to bring down this other stuff that we haven't touched. 3 squared. Actually, why don't we do 3 squared? Why not? 3 squared is 9, because 3 times 3 is 9. X squared, y to the 8th. We got a power to a power. We're going to multiply them. So we're going to do negative 2 to the 6th. Still hate that word. Terrible word. Oh, about to say it again, because this is y to the 6th, right? Now, we're going to deal with this. Negative 2 to the 6th. It's an even exponent, so it comes out positive, right? Because a negative times a negative times a negative, you get the point. All the way out, doing it 6 times, we end up with a positive. 2 to the 6th is 64. We can also combine these like bases. If you have like bases multiplied, what do we do with the exponents? Put it in the comments below. Nobody ever does that. Play along, people. It's okay. It's really okay. All right, so we're going to bring down 9 because we're not going to touch it. We're going to bring down x squared because we're not going to touch it. And then y to the 8th times y to the 6th. We add the exponents, which you should have put in the comments already. Just saying. Is y to the 14th. And then times, I can't remember if I said this out loud or not, but times 64. Negative 2 to the 6th is 64. If you put, by the way, just a side note, if you put that in the calculator, like if you put negative 2 to the 6th in the calculator for it to do that math for you, make sure that you put the negative 2 in parentheses, or else it'll spit out negative 64, because it won't know that you're wanting to square the negative as well as the 2. So word to the wise, when you put in powers of a negative in your calculator, make sure you put it in parentheses. Okay. Then 9 times 64 is 576. So this equals 576 x squared y to the 14th. There it is. First foray into exponents. Hope you enjoyed it. I know I did. If you're one of my students, I'll see you in class. If you're not one of my students, thanks for joining us. You can check out emberlearninglabs.com for everything else we're doing. Also, drop a like, subscribe. It'd be great. Thanks. Have a wonderful, wonderful day.